Good day everyone, my name is ClemJosephPareja and I'm here to discuss about the set of real numbers. So the set of real numbers is the union of the set of rational and irrational numbers. So what are rational and irrational numbers? Let's find out. So in elementary, we were taught how to count 1, 2, 3, 4, 5, the numbers go on. So we know that these numbers are used for counting. So this is what they call natural numbers or counting numbers. So counting numbers are numbers that are commonly used for counting, for measurements, and others. So what if there's nothing to count? We call it zero, right? So 0 plus the natural numbers makes up for the whole numbers, which are numbers that cannot be expressed in decimal form. So what if there's a loss? You have a debt to your friend, a loss in stocks, and a decrease in height. So this calls for a loss or negativity, which we call in math as negative numbers. So negative numbers and whole numbers are alike, but negative numbers have a negative sign in it. So negative numbers and whole numbers make up the integers. So integers are the negative and the positive, the yin and the yang, or the good and the bad. So the integers are the combination of the whole numbers and the negative numbers. So between these integers are numbers that cannot be expressed as a whole. We call them the non-integers, or we commonly call as fractions. So non-integers and integers can combine to make the rational numbers. So rational numbers are numbers that can be expressed as a proportion of two integers. 4/1, 3/4, 1/2, 1/3, you name it. These are rational numbers. So, but what if you cannot express these numbers as a ratio of 2? So we call them irrational numbers. So some examples of rational numbers are pi, the square root of 2, the square root of 3, and many more. So rational numbers and irrational numbers, as what I said, make up the set of real numbers. So now let's focus on integers. So today we'll talk about the properties of integers. So the first property is the closure property, which states that the sum of any two integers is an integer. So 2 plus 5 is just equal to 7, which is an integer. So 4 plus negative 52 is sum is 2, which is an integer. So the next property is commutative property. So in addition, the order of the addends does not affect the sum. So 4 plus 7 is equal to 7 plus 4. Negative 1 plus negative 3 is equal to negative 3 plus negative 1. So in multiplication, the order of the factors does not affect the product. So 5 times 6 is equal to 6 times 5. Negative 1 times negative 3 is equal to negative 3 times 1. So the next property is associative property. So in addition, changing the grouping of the addends does not affect the sum. So for example, 6 added to the sum of 7 and 3 is just equal to the sum of 6 and 7 added by 3. So 6 plus the sum of 7 and 3, which is 10. So when you add, it becomes 16. So 6 plus 7 is 13, added by 3 is 16. As you can see, they both are equal. So in multiplication, changing the group of the factors does not affect the product. So for example, the product of 4 and 2 multiplied by 5 is equal to the product of 2 and 5 multiplied by 4. So the product of 4 and 2 is 8, multiplied by 5 is 40. Well, the product of 2 and 5 is 10, multiplied by 4 is also 40. So the fourth property is the distributive property. It says that the distributive property, multiplication over addition, states that if a term is multiplied by a term in the parentheses, we need to distribute the multiplication over all terms. So here's an example. The sum of 5 and 3 multiplied by 2 is just equal to the product of 2 and 3 added to the product of 2 and 5. So the sum of 3 and 5 is 8, multiplied by 2 is 16. While the product of 2 and 3 is 6, and the product of 2 and 5 is 10. 6 plus 10, 16. So 16 is equal to 16. So the next property is the identity property. So for the addition, the sum of 0 and any number is the number itself. So anything you add to 0 is still the number itself. There's no change. This means that 0 is the identity in addition. So for multiplication, the product of 1 and any number is the number itself. So anything you multiply to 1 will still be the number. So 1 times 5 is 5, 5 times 1 is 5. So which means that 1 is the identity for multiplication. Next property is the inverse property. For addition, for every number n, there is such number where n plus negative n is equal to 0. So which means that so the last property is the inverse property. So in addition, the inverse property is for every number n such that n plus its negative is equal to the 0 or the identity. So the inverse of n is negative n. So for multiplication for every n except 0, so n times 1 over n is equal to 1. So the multiplicative inverse of n is 1 over n or its reciprocal. So all real numbers, integers, and alike form a straight line. We call it a real number line. So this is an example of a real number line. Well, all the numbers to the left of 0 are negative and the numbers to the right of 0 are positive. So these numbers have a certain distance from 0 and we call it its absolute value. So the absolute value is the distance of a number from 0 denoted by 2 vertical bars. So there are points to remember. So we're talking about the distance, so there are no negative distance. So the absolute value of a number is always positive. For example, the absolute value of 5 is 5. And the absolute value of negative 5 is positive 5. So there's no negative distance. So 5 and negative 5 are equidistant from 0. So goes to 9, which is the absolute value is 9. And negative 9, which has the absolute value of 9. So, in the number line, 5 and negative 5 are equidistant from 0. And 9 and negative 9 are equidistant from 0. So that's all for today. Thanks for watching. If you have more questions to ask, just click the link below and answer the questions that follow. God bless. Have a great day.